Hello, and welcome to Orbiting Earth. My name is Nathaniel Chardine, and I am a production designer at the UWM Manfred Olson Planetarium. We are so excited that you could attend today's event, and we want to extend a huge thank you for your support. We had so much fun putting together this program in celebration of the first 20 years of the International Space Station. I personally had a fantastic time learning about just a few of the groundbreaking discoveries scientists have made while flying above our beautiful planet. We'll look at experiments that range from growing food in space to the physics of fire and water in microgravity. But, perhaps most inspiring of all, we'll experience just how important international collaboration is. After the show, be sure to stick around for a question and answer period. With that, please join me in welcoming our presenter, Planetarium Director and Astronomer Dr. Jean Creighton.
Thank you all for being here. Nate and I did have a wonderful time thinking and learning more about this huge lab, the size of a football field that is floating around Earth, doing experiments, helping us understand how space affects us, and trying technologies that can't be tested on Earth. This is not a new idea, right? This idea of having an international space station is not new. The first designs that we could find was in 1929, and this wheel that you see might look a little familiar to you because it inspired the space station that we see in the famous movie 2001: A Space Odyssey. Reality happened in the 70s and 80s. Americans put up Skylab, and the Russians made Mir, means peace in Russian. And these experiments gave us wherewithal of how do you do that. And then other countries wanted to be involved. Everybody was keen on sharing the bills. So in 1993, there was an announcement that an international space station will be built that will involve multiple countries. And this, in fact, is the largest thing we've ever put in space, and it is the most expensive project that we've built. 19 countries have been involved from all corners of the Earth, 239 people with over 2,500 experiments. So this has been a very fruitful lab. You can't get something that big on one spacecraft. You obviously need it to be built piecemeal. This required a tremendous amount of planning. It required very carefully determining how people, our astronauts, are going to kind of build things, connect things, and hoping that everything works together. So let's watch how the International Space Station was put together, starting with Zarya, which means dawn in Russian. So there is the beautiful International Space Station and it's all its glory. It took a few years to put it together. We are going to visit it, okay? We're going to take a tour of the Russian segment of the International Space Station. And I just want to say that maybe you've always wanted to be an astronaut, or maybe it's Friday and you are tired of sitting around. Either way, you can follow along with our astronaut and you can float from your chair thanks to Zoom. So you can do something like just this.
So we're going into the Russian segment. Be ready. You don't need a passport either. This is Yevgeny.
Hi.
Doing a little tour. This is the FGB, and what's cool about this module, it is actually the very first piece of the space station that came up in 1998. Można? Snimają? Чуть-чуть. So here we are in the heart of the space station, really. This is the service module. This is the central post. And what's cool about this module, of course, it's the central post. It also has great windows right down toward Earth. It has controls to fly in visiting spacecraft if they need some assistance right here. It has Russian computers as well as American computers to help us control anything we need to on the space station. It's a couple of our crewmates back there, Oleg Novinsky on the right and Yuri Malenchenko on the left. Yuri, what are you doing? Что делать?
Coffee.
Making coffee?
Yeah.
Oh, black coffee.
Yeah.
Looks good.
I love the fact that the American speaks Russian and the Russian responds in English. I guess that's the sign of an international collaboration. I did mention that this is primarily a lab, right? So we're going to take a look at some of the projects that people have been working on in this lab space. And you can imagine that one of the very first things that we needed to figure out is, can we grow food on the International Space Station when we're thinking about expanding our horizons to, say, having a base on the moon or maybe eventually going to Mars. So think about it. Here are some really young plants. Look at the roots that you can see in the ground, in the soil. What do you think? Are they going to do that? Are they going to grow like this in space? Think about that. Are they going to go downward? Is that something that has to do with gravity, or is that something else? We didn't know. So we had to make sure that plants grow. So let's see what we found in space. I would argue that these roots are more or less the same with Earth. They certainly don't go every which way. And that told us that roots in the ground aren't responding to gravity. The main reason why they move away from the original plant is because they're looking for more nutrients. Well, that's good. That means that food, even in principle, can grow in space. Of course, you need more than just soil, you need water. And it sounds like watering plants is one of the most tedious things that astronauts have to do. So there was a real desire to figure out how to eliminate some of it, make it a little more sort of efficient. So a system was delivered that you can put water in a tube, the water stays in a reservoir, and then as the plant needs more water, the little doors open, water is allowed in when the plant has enough, and all of this happens automatically. So that means that these plants can get just exactly what they need and no more, which saves time and water in the scheme of things and keeps the plants happy. You've got the water, but what about sunlight? There's no sunlight, nothing certainly in the space station itself. So they built these chambers that are packed with LEDs, and the LEDs serve as basically energy, forms of energy. And there are a couple of things here that are interesting. You see a combination of blue, red, and green. Only the blue and red LEDs are necessary for the growth of the plant. The green lights were put in so that when astronauts look at this food, they don't think, that looks too psychedelic for me. I mean, it was really bright neon purple. It doesn't look so appetizing. So they added the green lights for psychological purposes so that the astronauts who see the food, who see the plants grow, identify this potentially as a satellite later on. Another little piece of trivia is that, which turns out to be rather profound, is that they noticed that the astronauts who took care of plants and had their hands in the chamber had whatever scratches they got heal faster. It's not well known that scratches in space do not heal, either at all or very slowly. And we think this is somehow connected to our immune system's response to microgravity. The key thing here is that we have figured out some of the healing properties that infrared, these LED lights have. And it turns out that they're capable of healing not only simple skin injuries, but also eye injuries as well, and might have ramifications for very real diseases like macular degeneration on Earth. So we talked about this chamber, right? We can provide all the light that we need, water, everything is good. The problem with such a space is that it can accumulate more gases than really is good for it. And this, in fact, is true throughout the International Space Station. Filtering the air is a real concern.
Ethylene is the reason that fruits and vegetables ripen.
But the problem was, in space, we're going to have a very confined environment, so the ethylene concentration can build up.
So the ethylene removal system that was developed draws air through a reaction chamber. The air is passed across a catalyst bed, and that catalyst has the effect of removing anything organic from the air. That includes mycotoxins, bacteria, viruses, and even mold.
So we had our first crop of green salad. I should point out, so I love salads. I can only imagine how hard it must be for astronauts to eat food that's kind of boring and without texture. So being able to grow something that's yummy and crunchy must be a real plus. I should point out, I smiled when I read that when they get supplies at the International Space Station, they usually get a few precious fresh fruit. And there's a party because they're so happy to share a couple of strawberries. In any case, the first crop we got was in 2015, and we're seeing here some astronauts who are enjoying their very own grown lettuce. We're going to take a look at some fun with food here. Good cat. There's a space pizza party for you. Now, food, of course, is principally for sustenance, but we're starting to wonder whether having green things, plants around you actually has real is beneficial for psychological purposes. It is, after all, some part of home, right? It feels a piece of earth. You take care of something, and this might turn out to be really important for long trips, like say Mars. You would have to have a lot of food growing. But as I said, again, it might have psychological benefits, and maybe we should take a note on that while we're in isolation, or more isolated than we normally are. Maybe having a plant in the house is something worth considering. We've talked quite a bit about food, since obviously it's a critical component of having a long trip in space. I'd like us, though, now to consider the lab aspects where we study the physics of the cosmos. And in some cases, it changes what we think is normal. We're going to look at the study of fire here. And I should say right away that a fire on the International Space Station is probably the most dangerous thing. You would only have fire in a very controlled environment in this combustion rack. So let's consider, when we think of a flame, what comes to our mind? I'd say most of us think of something like a candle, right? We have a very specific shape for the flame. We have a certain color change. This is very familiar to us. Even I was surprised when I saw what a flame looks like, what a candle looks like in microgravity. Quite different in shape, quite different in color. And in fact, the fire, if you will, is just that very thin skin. Let's see what that looks like in the chamber when we can really have a serious ignition. I'm actually looking, I just took a look at the comments, and I don't think I mentioned, you're very welcome to ask questions in the chat box if you like. You can wait until the end if you wish, but you're certainly welcome to ask questions as they come to you. A different kind of fluid is water, and we so associate the movement of water with gravity on our planet. So it's nice to kind of broaden our horizons. Chris Hadfield is going to show us here what happens when we saturate a face cloth and we try and wring it out.
Okay, so here's a soaking wet washcloth. Get the microphone so you can hear me while I'm talking. And now let's start wringing it out.
What do you think will happen? What's going to happen to that water? I can almost hear the sound, right? Shh. Let's see.
It's really wet.
This is my favorite part. Look that up.
It's becoming a tube of water. The water's all over my hands. In fact, it wrings out of the cloth into my hands. And if I let go of the cloth carefully, the water sort of has it stick to my hand.
Water is a big deal in space, and for the International Space Station, with so many people involved over 20 years, it was decided that water will be recycled. This meant that we needed to design a filtering system, and in 8 years, it was capable of saving over 22,000 pounds of water, and $225 million were saved, which means that it paid for itself. And this kind of technology meant that we could help people on Earth, of whom there are many, who don't have access to clean drinking water. In this region of Mexico and Chiapas, we're able to use that filtering system to bring drinkable water to people, which is a wonderful, wonderful cause. We learned something, by the way, from that water replenishment system. And that is, at first, it wasn't as efficient as we expected. So it was delivering about 75% of the water that we thought. And when people looked at the filters, they realized that there was a lot of calcium on the filters clogging up the system. It turns out that as people were recycling urine and perspiration, calcium was sticking on the filters. And that meant that it told us that the astronauts were losing more calcium than we expected, which is why they have a 2-hour regimen every day of weight training to try and combat the weightlessness that makes bones kind of lazy. And this is also giving us some insights about how to help people with osteoporosis on Earth. For example, we found out that a low level sodium diet helps. Fun fact: what part of the body might become sore, right? So you see two little red circles at the feet, but you could have thought, oh, it's the head because fluid collects in the head. It doesn't go down to the feet thanks to gravity, which is true. And eyes can get sore because, again, fluid kind of builds up behind the eyes. But it turns out that it's the top of the feet that gets sore unexpectedly. And that's because astronauts have to stabilize themselves, right? When they're working on something, they can't just be floating around. And if they need to change direction or talk with someone, they use these bars that you see on the ground, and they hook their foot under the bar to keep them nice and steady. Well, the tops of our feet are not used to that kind of constant friction, and that's what ends up being sore. On the way back, when they come back from the Earth, well, then it's the bottom, their soles of the feet that get sore because they're not used to carrying our weight, and they're not used to constantly being in contact with the ground. So there's some fun trivia for you. Now, in addition to monitoring the effects on people, we're also monitoring the effects of basically climate change, mostly on Earth. We're monitoring the Earth for a variety of reasons, including the health of crops and so on. But let's see here some natural disasters. Thanks to this observation area, we can use fairly inexpensive regular cameras to take pictures that really are helpful, because we see anything from storms, wildfires, flooding, the bleaching of coral reef. And it's not just so that we can see it, but it's also to help coordinate relief efforts on the ground. For example, in this flooding picture, people were able to identify where might they be able to safely get supplies to help with the recovery process. So I've mentioned now astronauts looking at the Earth, and every astronaut talks about how seeing the Earth from above changes their perspective of what Earth represents for them, how they're connected to it. And this is called the overview effect. And I'll let the astronauts describe it for you.
The entire experience is actually very surreal. First, you're launched on a rocket. You're pulling G's as you're going out of the atmosphere. You're looking at the Earth for the first time. You're floating. Everything is different, and it just is all just such a different experience that it almost doesn't seem real.
You get these beautiful, twinkly city lights, seeing where all the people are and where they aren't. And one of the most impressive things was watching thunderstorms, storm activity moving around the planet. It's like watching neurons firing in a brain. These tentacles of light that are just connecting and traveling. Yeah, it might be starting over Florida, but it's moving across the ocean to Africa as far as you can see. And I remember floating there just thinking about, oh my gosh, everything is connected.
It was just incredible. Everything looked so large. But again, the most significant realization to me was looking out and realizing not how far I was from Earth, but how close I was to Earth and how connected I was to Earth, and how, we on the space station plus everybody on Earth and this planet is actually so small compared to this vastness of outer space.
What has always struck me every time I went there is how beautiful the Earth is, how fragile it looks, how alive it obviously is. But it's the death around the Earth that's startling. how this beautiful, shining oasis of life is there naked in the middle of pitch black. It's a finite system, a closed loop system. There's no new air, no new water that gets to Earth ever. It's all recycled and has been for billions of years. And it is perfectly balanced and perfectly matched to our needs. We are matched to her. That concrete realization that we belong to Earth and not vice versa, it's kind of a mental shift to see that we just nowhere else we could go. We can talk about colonizing other planets, but you know, kind of smarter and cheaper to just take care of Earth as she is.
It started to make me understand that everything is connected. What is happening in the ocean over here can affect what is happening on land over here. It's just all one being, and it's all interconnected. And so I think we tend to live in our bubble of our world that's here, and it's hard to think about other people on the other side of the world and be empathetic toward them, really, because you don't know them and you don't know their situations. And I found seeing the Earth really changing that perspective for me.
It's amazing how space unites everyone, despite from which country you're coming from, or from your religion or your background. It's unite everyone. So it's really important to focus in this aspect and to focus in this front to exploring space, because somehow everything is dissolved. All these political issues, all borders dissolve.
It is wonderful to think that if we have the capacity to work together to make something like the International Space Station, surely we have the ability to protect the Earth and take care of our planet. You are able to see the International Space Station for yourself. It's a bright object and it travels fairly quickly across from horizon to horizon. You can look it up from spotthestation.nasa.gov. And I should point out that this work that's being done to find technologies that help us in space and help us on Earth also take place in Milwaukee, in Wisconsin, and we're planning a series of talks called MKE Space Tech that will begin in November. Before then, we have other programs as well. I'm very excited about Music and Stars of Chile. We have a Chilean astronomer who works for ALMA and who has a real fascination with music. He was able to transpose sounds from the ALMA instrument into music bits that people can use for making music today. And he will talk about that project as well on September 30th. And for Harry Potter fans, we have a trivia fun program, Fantastic Beasts in the Sky, that of course will be virtual and will be in mid to late October. With that, I'd like to thank very much the College of Letters and Science and the Center for Gravitation, Cosmology, and Astrophysics at UWM, and of course you for participating in the program today. And as I said before, I'd be very pleased to answer questions that you might have. Thank you. You look forward to the November talks. Yes, I should point out, since you mentioned November specifically, Joyce, we also have a series of programs, 5 of them, and from November to December, called Under African Skies. We have 5 people from 5 different countries from Africa who will discuss how about their culture and how also it connects to I want to say the heavens, the sky, and celestial bodies. While you're thinking of your own questions, I would like to address an obvious one, and what is the future looking like for the International Space Station. Right now, it sounds like the funding for the International Space Station on the NASA side might shift, and it could be that NASA is more of a client to the International Space Station. At the moment, there are 50 companies that use the International Space Station labs for research and development, and I guess NASA would be one of them. So we're hoping that the work will continue beyond that. So you should be able to put any questions that you have in the chat box. It's been wonderful to read all the different aspects of living on the International Space Station and how people prepare for that experience. One thing is certain, for the selection of who gets to be on the International Space Station, it's not like it used to be, with the Apollo missions. You just needed to be an excellent pilot. You needed to be the best pilot, a great engineer, troubleshooter, that kind of thing. And what table manners you had was less important. But when you put people in a fairly small space for months at a time, you need people who will work well with others and de-escalate any tension so that people can be as productive as possible in space. So I found that to be interesting. Let's see what other questions you might have. What research project that has been conducted on the ISS do you find the most interesting? I think I hinted at it, this whole idea that you can use infrared light to heal wounds, even serious wounds like from a laser on the eye apparently can be healed. Pilots, I guess, suffer from this. Is a wonderful frontier because there are, I forget the number now, but there are millions of people who are impacted, say, by macular degeneration. And it's believed that this kind of carefully controlled infrared light can help with that. So it has many applications on Earth. I can't even begin to imagine the training that takes place to be able to do these different experiments. I'm guessing that the experiments, they're probably experiments that do require very fine tuning in terms of getting it right. But I imagine what's really difficult, the thing that people spend hours and hours practicing are the spacewalks. That is so highly choreographed that literally every move you make, you've practiced because it's hard. It's really hard. So I understand that training for those spacewalks happens in these huge pools. A pool kind of feels like space in terms of how buoyant you are. And that gives them some sense of, okay, now I need to do this. And now I need, like, as I said, very carefully choreographed. I think that's the hardest thing. What is the average length of time that an astronaut stays on the International Space Station? You know, Matt, I don't know. My guess is 5 or 6 months. And the longest time a person has been in space, I believe, is almost 3 years. A Russian gentleman whose name at the moment escapes me, but he was in that odd circumstance where he left the Soviet Union and he came back to Russia. How much food is currently grown on the ISS, and are there plans to grow greater quantities in the future? I don't believe I don't believe that the food that's grown there is enough to count, is enough to meet the needs of the astronauts. That would be a treat. I'm not sure if it's an issue of expense or why that is, but it seems like, well, I guess I should put it this way. If the food doesn't work, if something happens and the food doesn't work, then there's no dinner, which obviously isn't a satisfactory arrangement. I think the food is considered bonus. If we get it, great. And if we don't, we don't. But it's certainly accumulating information, accumulating data, so that when we do go, let's say, to Mars, we're confident that we know how to grow the food in a reliable way. In fact, I was watching a video that I found fascinating. There are people now who are studying how can you use soybeans, which you could pack in large quantities. Since they're so versatile, you can make different things so that when you're on a trip to Mars, or when you are on Mars, you can cook a variety of things from just one bean, which also has all the nutrients that you need. Right now, there are several upcoming missions where astronauts will be there for 6 months. Yes. The current crew on the ISS will return to Russia in October. Yes, Joyce, thank you. The experiment that you might have heard of was the twin experiment, as it were. Scott Kelly was in the International Space Station, and his brother was on Earth. They're identical twins, and they wanted to see how their bodies would differ after Scott Kelly spent a year in space. So that was interesting, because Scott got a little taller since gravity wasn't dragging him down, making him shrink. He was a little taller than his brother, which I imagine he didn't let his brother forget for as long as it was true. Any other questions? Why did they stop expanding the ISS? I think they had reached the capacity that they wanted. So my understanding is that since it's been in space, the first pieces went up in '98. It could be that it's coming toward the end, possibly, of, I don't want to say the end of its life, but it might not make sense to have a huge investment of putting something else when it might not stay there for many years. So people are kind of switching, pivoting a little bit to maybe building a base around the moon. So that might be where NASA focuses its attention, and possibly other countries too. So I think at this point, we're really happy that it's working. We're happy to keep it going, but maybe having something brand new is on the International Space Station might not make much sense at this time. When they are done using the ISS, are they going to return it to Earth? What will they do with it once it's past its life? Well, all these kinds of things, if you don't do anything, if you don't rev your engines, because otherwise it would lose, I forget how many centimeters it is a day, but something like 20 or 30 centimeters, maybe it's even feet. It would get pulled to the Earth if we didn't keep it afloat, if we didn't keep it moving fast. So if we don't have engines, eventually this is going to fall to the Earth, and this is going to be one of these situations where you'll want to control where it falls so that it will burn through the atmosphere. But even if some chunks remain, that they would fall somewhere where it wouldn't be dangerous for people. These would be very controlled schemes. Thoughts about the commercial crew program? Well, People like to remind us that NASA's history involved collaborations between NASA and the private sector. So NASA would go to a company and say, I need this to do this. And NASA's brilliance was to specify exactly what is it that they needed. And then the companies would try and build exactly what was required. So I feel that there's a time and a place. There might be really good reasons for these collaborations to continue and maybe be expanded. But I would also say that I would like some oversight. I would like to make sure that there are people having oversight over what all is going on. Matt, what does the collaboration look like among the various countries on the ISS? Do each of the countries have their own projects, or are they all working together on all projects? No, they tend to have their own. So each space agency is going to have their projects, and their people, as it were, will be working on that. I believe that most of the time, everybody's in their own little space and doing their own thing. And it's certain holidays that people all get together. It's more of a social thing. Of course, emergencies also will get everybody sort of focused and let's all figure this out. But yeah, people are doing their own sets of requirements. What's interesting, I was reading about this recently, that one of the very first crews at the International Space Station was incredibly efficient, incredibly quick at completing all their tasks. So then the next group of people who came, they were given the same kind of pace. In fact, they were given, the newbies, the pace that had been established by the time the first crew had finished. So when they were really, really fast and efficient. Well, these people couldn't keep up. They couldn't, they weren't feeling well enough, right? It takes a little bit of time to get oriented in weightlessness. It takes a few days for your tummy to settle, to become as efficient as you need to be. And every time you don't do a task, that means that somebody has to run a code, and everything that you do for the rest of the time you're there will change from day to day, right? So this is a very, again, highly choreographed exercise. And people realized, people take a little bit of time to get used to the situation, and you need to adjust for that. Has anyone on the ISS gotten seriously injured or been very sick? How is that handled? Now, this is the sort of thing that people wouldn't talk about. The answer is I don't know that anybody's been seriously injured or been sick, but I can tell you this, that there was a simulation of a space base, let's say on Mars, where people are in, an enclosed space, and they're supposed to live life as much as they could, as close as they could to Mars, right? So it takes 40 minutes to communicate with anybody outside your enclave, that kind of thing. One of the people working there, however, got electrocuted. There was some problem, and the person and the group was frozen, because on the one hand they felt responsible for this person, that they had to get a medical help. On the other hand, they worried that, well, does that mean that we're failing the experiment, that we, what would we do if we were on Mars? And in the end, they decided to stop the simulation and get medical help for the person. But of course, if you're on the International Space Station, that's not really a choice. So people do have medical training. I understand that for some routine things, I think they have them practice. but I don't believe there's been a very serious injury. Joyce tells us that an astronaut who had his helmet filled with water while doing a spacewalk, yes, and that was serious, but I wouldn't call that an injury. That would be a serious problem that they had to solve. So that was one of these, they have to work the problem. So you tell the ground, this is what's happening, and they get everybody and their dog to figure out, okay, with a clear mind, they've slept in their beds, how are we going to solve this particular problem? That's also extremely interesting to see that all these sort of people are figuring out different solutions, and when they come up with something that's workable, you know, that's what they present to the astronauts. If you haven't seen Apollo 13, apparently it is a very close, it's a very true representation of how they solved a very serious problem indeed. Any other questions or comments? I'm glad that people are chiming in with things that you know. I would recommend, if you haven't, I would recommend reading the book called Endurance by Scott Kelly. And also, I will forget the title, but I hope that Victoria, who's behind the scenes here, will help me. Chris Hadfield wrote an excellent book that I highly recommend. Something like Lessons for Life on Earth, Astronauts' Lessons from Life on Earth, something like this, where he talks about the training, but also some of the things, thank you, An Astronaut's Guide to Life on Earth. So the, I just wanted to say this, that one of the things that struck me was Chris Hadfield talks about aiming to be a 0. So you can be a +1, helpful, 0 is kind of neutral, and -1. And you can imagine these super competitive people are very efficient, and they want to do as much as possible for you on the space station. They want to be as useful as possible. But it turns out that when you're new to that, it's better to stand back a little bit and see what is necessary. What are more experienced people needing to do? What are they tired of doing? Where do they need help? Kind of stand back and then step in. Aim to be a 0. Aim not to be harmful, I guess. And then as you get more experience, you can be more of a +1. All right. Good luck with your research, Joyce. She's doing research on the International Space Station. How do astronauts on the station communicate with their families? They talk over satellite. So they have a line where they talk. I'm thinking that communication now is a lot easier than it used to be. I'm assuming that it happens, I've forgotten now, but I think they have the capacity to be speaking at least briefly every day, I think. Any other thoughts or questions? Well, I certainly wanted to thank you for participating. It's wonderful to have people's attention. I do hope that you join us for other programs. We're excited. We miss having people in person, to be sure, in the planetarium. But on the other hand, a virtual experience like this allows people from all over to join us. I believe I have family from Calgary today who might be joining us too. So Again, thank you all very much for joining us, and I hope that you're able to see one of our future programs. Thank you so much.